Okay, the last thing we're going to talk about before we take a quick assessment to make sure that you're up to speed with everything that we've been doing for this past week is, okay, what if I have to convert from, let's say, atoms to liters or atoms to grams? Is there a way to do this? Well, the answer to that is yes, right? We don't have a direct relationship between these things, but what we do have is our fellow mole that we can use to move from one unit to another based off what we're dealing with, okay? It's kind of like a mole roadmap, if you will. So picture the mole as kind of the bridge that you use to get from one thing to another. Call it a mole bridge, okay? When you're given one thing and mole is not in the question, you must use 2 steps in your conversion, okay? So for instance, if the question says, how many grams are in blah molecules, you're going to have to go from molecules to the mole, and then the mole to the grams through molar mass, okay? So we're going to use this idea of the mole bridge to solve the following problems. Okay, so let's look at the first one. I'm going to move over here because I don't want to be in the way. Actually, I'm going to move down here. Okay, so the first question states, how many grams are there in 1.4 times 10 to the 20 atoms of plutonium? Okay, so I just set this up exactly like I've set it up in the past, where I'm going to say, question mark, what am I looking for? So the question mark is grams, specifically of that of plutonium. And the problem gives me 1.4 times 10 to the 20th atoms of plutonium. Okay, now I'm going to set a conversion up, but let's kind of develop a game plan here first, okay? So I have atoms, okay, atoms. So I need to move to the mole using Avogadro's number, and then once I get to the mole, I can use molar mass to get to grams, okay? So the first thing I have to do is cancel atoms of plutonium. So atoms of plutonium have to go into the bottom of the conversion. And luckily, I have a direct relationship from atoms to the mole. So I can put moles of plutonium in the top. Okay? So atoms cancels, but I don't have the unit that the question was actually asking for. So I have to set up another conversion. Here comes the mole bridge, right? So here's the top of the mole bridge. So then the bottom of the mole bridge has to go into the denominator of the second conversion. So this is going to be moles of plutonium. And thankfully, I have a direct relationship between moles and grams through molar mass. So grams of plutonium can go in the top. So now moles cancels. I'm left with the unit that I want. So now I can plug my numbers in and solve, okay? So for every 1 mole of plutonium, I will have 6.02 times 10 to the 23rd moles of, or atoms of plutonium. And then for every 1 mole of plutonium, it will weigh, I think, 200 something, but let's see here. Plutonium weighs 244. You see that's all the way up at the bottom. 244 grams of plutonium. Okay? So now I'm going to plug this into my calculator. I'm going to go 1.4. So let me move this up. 1.4 E20 times 1, which is just itself, divided by 6.02 to the 23rd times 244 divided by 1, and I get 0.0, watching sig figs, I just need 2, 57 grams of plutonium. Okay, and I'm going to take a step back here and kind of think, does this make sense? Okay, so if I'm starting with less than 1 mole of plutonium, right, because 1 mole of plutonium would be 6.02 times 10 to the 23rd, I would expect the mass to be way less than its 1 mole of gram, which is 244. And yes, that just so happens to happen with my answer. Okay? All right, let's do another one. this says, how many grams are there in 2.35 liters of O2? Now notice how there's no mole in this problem at all, okay? Which means I have to use the mole in order to get from one to the other, okay? So that's what I'm going to do. I'm going to say question mark grams of O2 is equal to 2.35 liters of O2. Okay, and we're just going to assume standard temperature and pressure. Okay, so let's set up the first conversion. I can move from liters to mole. Okay, so liters is going to go to the bottom, and moles of O2 can go into the top, right? So then liters cancels, but I don't have the unit that I want, so I need another conversion. So I need to put moles in the bottom for it to cancel. And this time I do have a direct relationship between moles and grams, so I can put grams of O2 in the top, okay? So moles cancels, am I left with the unit that I want? The answer is yes. Therefore, I can plug my numbers in and solve. So I'm going to say for every 1 mole, there will be 22.4 liters. And for every 1 mole of O2, it will weigh 32 grams. Now be careful, don't say 16 because O2 is 2 atoms of oxygen, so you need to do 16 times 2. Okay? So let's plug this in. So I'm going to do 2.35 times 1 divided by 22.4 times 32. So this turns out to be, with 3 sig figs, 3.36 grams of O2. Okay? I'm going to do one more problem here. Number 3, and I'm going to let you do number 4 by yourself. It says, how many atoms are there in 25.7 liters of N2 gas at STP, standard temperature and pressure? So I'm going to say question mark, atoms of NO2 gas is equal to 25.7 liters of NO2 gas. Okay? So the first conversion I have to do is get rid of liters, so liters of NO2 to moles of NO2, and then moles of NO2 to atoms. Well, it's actually going to be molecules because it's a molecule, not an atom. Okay, sorry about that. To molecules of NO2. So I'm going to say for every 1 mole, there will be 22.4 liters, and for every 1 mole, there will be 6.02 times 10 to the 23rd molecules. So then I'm going to plug this into my calculator. Okay, so now if I plug this into my calculator, I'm going to do 25.7 times 1 divided by 22.4 equals times 6.02 23 divided by 1, which is just going to be the same number, and I'm going to get I need 3 sig figs, 91 times 10 to the 23rd molecules of NO2. Okay? Now, I'm going to say this does make sense, right, because I'm solving for molecules, so I would expect my number to be very large. Okay, so there's one more problem that I want you to go ahead and try, and it's number 4, and you're moving from grams to liters. So go ahead and try that one. Thanks.